All right, we're going to do part 2 of factoring trinomials. So this is chapter 8.6. We're going to factor trinomials of the form ax squared plus bx plus c. All right, now typically when we had a trinomial, we wouldn't have a number in front of that x term, right? So we might see something like that, right, without the a in front. Right, so we had like an x squared plus bx plus c, and all we had to do was find what multiplied to the last and adds to the middle. All right, now if there's a number in front, typically the first thing that you should check is if there's a GCF, right? So check if there's a greatest common factor, right? In this first example, 5x squared plus 15x plus 10, look at all of your terms. Notice that 5, 15, and 10 share a factor of 5. So you're able to take out that 5. Now, if you take out that 5, whatever you get on the inside is what you get when you divide everything by 5. Right, and so we're left with x squared plus 3x plus 2. All right, now this on the inside, x squared plus 3x plus 2, you are able to factor that with the skills that we learned in the previous lesson, right? So we're looking for factors of 2 that add to 3. That's just 2 and 1, right? 2 plus 1 equals 3. Right, so this is going to become x plus 2 and x plus 1. There is a 5 out front, so we need that in our final answer, right? This is our final answer, right? And if you were to multiply it, if you were to FOIL it and then distribute the 5, you do get the original expression, right? So in all of these problems, check first if you can take out a GCF. You're not always going to be able to, right? Majority of the problems in this video are going to be problems where you cannot take out a GCF, right? And I'll show you how to do problems like that. All right, so when you cannot take out a GCF, right? So let's look at example A, 4x squared plus 13x plus 3, right? Between 4, 13, and 3, they don't share any common factors other than 1, right? And if they share a factor of 1, you don't want to take that out, right? That's a little redundant. So what we do instead is we do similar skills to what we did in the previous lesson, and we're going to find what adds to the middle term, right? In this case, our middle term is going to be 13. That was our B term. Our C term was this last term right here, but we need to take into account an A term, right? Our A term is whatever's in front of that x squared this time, right? So now we don't just have a blank, right, x squared, right? If it just looked like x squared plus 13x plus 3, we were able to just find what multiplies to the last, adds to the middle, right? When there's something in front of it, the first thing that you have to do is multiply a and c, right? So you're going to do a times c to get a number, right? And in this case, a is 4, c is 3, 4 times 3 is 12. All right, now this number, AC, so this is our AC, we need factors of 12 that add to 13. All right, now if you think about it, a lot of you can probably in your head think of the factors of 12 that will add to 13 if you can't just list them out. 1 and 12 are factors that if you add, they're going to add to 13. All right, so this is going to be the pair of numbers that we're going to use. All right, so what you can do in this case is do it the same way that we did before, right? So we're going to do x plus 1 and x plus 12, right? The only difference, since I have a number in front of my x squared, in this case I have a 4, I'm going to divide each of these numbers by 4, all right? If it divides, then you simplify it, and if it doesn't, then you slide that number out front. So x plus 1 divided by 4, I'm going to go ahead and slide that 4 up front. It's going to be 4x plus 1, all right? And then x plus 12 divided by 4, 12 divided by 4 is 3. All right, that does work out perfectly, so you don't need to slide anything there, right? And so this is your factored expression, right? I call this the slide and divide method. I heard another teacher use this method some time ago, and I feel like it's one of the easier ways to factor a trinomial where a equals a number that's not 1. So that's what I'm going to do, and that's what I'm going to stick with for this lesson, right? There's a couple other ways that you're able to do it, but I'll let you guys see those in Algebra 2, right? So as long as you can do it in this way, then you'll be fine. All right, let's do the same thing with the next one. All right, so same exact idea. We have an ax squared plus bx plus c, right? So our a is going to be 3, our b is -7, our c is positive 2. Right, so we're going to do a times c. Right, a times c is going to be 3 times 2, which is 6. So I need factors of 6 that add to -7. All right, since I want to multiply to a positive and add to a negative, I should expect the same sign, so 2 negatives. All right, factors of 6 are going to be 1 and 6. Since I want them to add to a negative, let's consider the negative factors. And if I did -1 minus 6, that does in fact get you -7. All right, so these factors work. I'm going to use -1 and -6. Once again, set it up exactly the same way that we did in the previous lesson. X minus 1, x minus 6. All right, but from here, notice that we have a number in front of our x squared, so we need to divide each of our numbers by that. All right, so slide and divide. If we cannot simplify, slide that number out front. This is going to be a 3x minus 1. Right, and then divide, right? 6 divided by 3 gets you 2. That does simplify, so I just simplify it and leave it as my answer. All right, and that's how you would do these kinds of problems. All right, so now let's do the same thing with this example. This is when a times c is negative. Same exact idea though, right? A is 2, b is -5, and c is -7. AC is going to be 2 times -7, which is -14. And I want factors of -14 that add to -5. Right, some factors of -14 are 7 and 2. Right, but keep in mind I want them to multiply to a -14, so I'm going to make one of them negative, the other one positive. So I'm going to consider both options. That's fine for now. If they don't work, we'll just try more factors. Right, we can do -7 plus 2. And then this does get us -5, so I don't even need to check our other pair of factors, right? I know that -7 and 2 are going to work. All right, so now what we do is we do x minus 7 and x plus 2. All right, do not leave it like this, right? Because we have a number in front of our x squared, we need to divide each of our terms, each of our constants by that number. All right, x minus 7 divided by 2. 7 divided by 2 doesn't simplify. I'm going to slide that 2 out front. It's going to become a 2x minus 7. X plus 2 divided by 2, divide. It's going to get you an x plus 1. Right, that does simplify. All right, slide and divide. All right, same idea here. A in this case is -4, B is -8, C is +5. All right, so AC is going to be -4 times 5, which is -20, and I want factors of -20 that add to -8. Think about it. Hopefully you can come up with the factors. If you can't, just pick some numbers, right? Maybe 4 and 5. All right, one has to be negative, one has to be positive, since I want them to multiply to a negative. Maybe 2 and 10. All right, 2, -10, -2, 10. All right. So now let's combine. If I do -4 plus 5, that's going to get me a 1. Not what I'm looking for. 4 minus 5 is going to get me a -1. Also not what I'm looking for. 2 minus 10 is going to get me a -8. That is our middle term. That is what we're looking for. All right, so then this answer is going to become x plus 2 and x minus 10. All right, and then once again, you have a number in front with your x squared. So then I want to divide by that number. All right, x plus 2 divided by -4. 2 and -4 are going to simplify into 1 over -2. All right, x minus 10 over 4, that's going to get me x minus 5 over -2. All right, and then that's as far as you can simplify, so I'm going to slide these numbers out front. So it's going to become a -2 plus 1. All right, and then this next one, keep in mind negative divided by negative gets you a positive. All right, so I can go ahead and turn these both into a positive. So it's going to become a positive 2x plus 5. Oh, I forgot the x here, sorry. So negative 2x plus 1. All right, so you get something that looks like that as your final answer. All right, now let's do some examples. Here, notice you should always check if there's a GCF, right? And if you look, what should catch your eye is that there's a 3, and a 6. Those each share a factor of 3. So I can take out a 3, and then whatever I have left over is what I get when I divide everything by 3. All right, and then you're left with an x squared plus x minus 2. All right, and then this trinomial on the inside you're able to factor, right? We want to find factors of negative 2 that add to 1. All right, so it's going to be a 2 and a negative 1. All right, so this is going to get us x plus 2, x minus 1. Don't forget there's a 3 out front, so I'm going to leave it out front. All right, same exact thing with the next problem. 8, and 48, you can take out an 8. And then you're left with a v squared plus v minus 6. Right, divide everything by that GCF, and that's how you get that trinomial. All right, and so now this is just a trinomial that we can factor. We want factors of negative 6 that add to positive 1. That's going to be a 3 and a negative 2, right? 3 minus 2 is going to get you a positive 1. Right, if you didn't recognize it, you would just keep trying it until you found the factor that works. So we get 8 times v plus 3 and v minus 2. All right. Now, if you can't take out a GCF, you're going to multiply a times c. 3 times 6 is 18. And we want factors of 18 that add to 11. That's going to be 2 and 9. All right, if I do 2 plus 9, that does get me 11. All right, so then we end up with h plus 2 times h plus 9. Right, because there's a number in front of my h squared, I want to divide both of them by that number. 2 divided by 3 doesn't simplify, slide it. 9 divided by 3 does simplify, divide it. So you get something that looks like that. All right, let's do the same thing with the next one. 8 times 7, right, is 56. So I have factors of 56 that adds to 30, right? We can't take out a GCF here, so this is our only option. 8 and 7 are the most obvious choices, but if you notice, if you add these, you get 15. That's not what we're looking for. All right, you can keep trying. Some other factors of 56 are going to be 4 and 14. Again, if you add these, you get 18. Also not what we're looking for. Another pair of factors is going to be 2 and 28. All right, now if you add these, you get 30. That is what we're looking for. All right, so it's going to be m plus 2 times m plus 28. All right, keep in mind there's a number in front. You're going to divide both of these numbers by that number. All right, 2 and 8 can simplify to 1/4. 28 and 8 can simplify to, it looks like you can divide a 2 from them. Or I think you can divide a 4 from both of them, actually. So divide a 4 from both of them, we get 7 over 2. All right, if they can't simplify any further, slide. So we get 4m plus 1 times 2m plus 7. All right, now here, again, we can't take out a GCF, so I'm going to do 3 times negative 2, which is negative 6. I want factors of negative 6 that add to a positive 5. Some factors of negative 6 are going to be 6 and negative 1, negative 6 and positive 1. Let's see if that gets us an answer. If I do 6 minus 1, that does get you 5, so I don't even need to check the rest of them. All right, so this is going to be an n plus 6 times n minus 1. I have a 3 in front, so I'm going to divide both of these numbers by 3. 6 divided by 3 is 2. All right, 1 divided by 3, you can't simplify that. You're going to slide it. All right, let's do the same thing with the next one. I can't simplify, I can't take out a GCF, so it's going to be 4 times negative 3, which is negative 12. Factors of negative 12 that add to positive 4. Well, I know some factors of 12 are going to be 6 and 2, so I'm going to make one of them negative, one of them positive. All right, if I do negative 6 plus 2, that's going to get me a negative 4, not what we're looking for. If I do 6 minus 2, that's going to get me a positive 4. That is what we're looking for. All right, so it's going to be z plus 6 times z minus 2. All right, we have a 4 out front, so let's divide both of these by 4. All right, so it's going to be z plus 3 over 2, z minus 1/2, right? Simplify all the way. You can't simplify any further, so you slide the fraction. So it's going to be 2z plus 3. Slide that one as well. It's going to be 2z minus 1. All right, so anytime there's a negative in our first term, all right, so if you notice here, a is negative, a negative 3. That makes the factoring a little bit trickier. The first thing that you want to do is factor out a negative 1. So I'm going to take out a negative 1 from each of my terms, right? And if I divide everything by a negative 1, all that's going to do is that's going to change the sign of everything. So I get a positive 3t squared minus 11t plus 6. And then this is something that we're able to factor the same way that we've been doing before. All right, so I can do 3 times 6, which is 18. And I can find factors of 18 that add to negative 11. All right, so if it multiplies to a positive and adds to a negative, I want them both to have the same sign, which is negative. That's going to get me a negative 2 and a negative 9. All right, so then this inside is going to factor as t minus 2 and t minus 9. Because there's a 3 in front, I would divide everything by 3. Slide that 3 out front, we get 3t minus 2, t minus 3. There is a negative 1 out front, so I'm going to write a negative. You don't have to write a negative 1 as long as you write the negative, that's fine. All right, so this would be your final answer. All right, same exact thing with the next one. My a term is negative. We don't want that to be a negative, so we want to take out a negative 1 from this trinomial, and to do that, we divide all of our terms by negative 1. All that's going to do is that's going to change the sign of everything on the inside. So we get a 7v squared plus 25v plus 12. All right, so we need factors of, let's see, well, I want 7 and 12. All right, so factors of 7 times 12, which is 84, right? So I need factors of 84 that add to 25. All right, so this is going to get me, I know 7 and 12 are factors. Some other factors, 21 and 4, right? If you don't know these off the top of your head, you can try to make a little factor tree as much as you can, and then see what different combinations of factors you can get. I think 28 and 3 are factors. Right, I think 14 and 6, right? So these are just a couple combinations. If we add all of these, 7 plus 12 is 19, not what we're looking for. 21 plus 4 is 25, that is what we're looking for. All right, so I would go ahead and write v plus 21 times v plus 4. All right, because I have a 7 in front, I would divide both of these by 7. All right, 21 and 7 divide. 4 over 7 doesn't divide, so you slide it. 7v plus 4. And we had a negative out front, so I'm going to write that negative in my final answer. All right, so it's going to look something like that. All right, and that's how you factor trinomials where your first term is not 1, right? So a couple extra steps than what we did in the previous lesson, but majority of it is essentially the same idea as what we did before.